Okay, now we can start now.
Okay, I'll start sharing my screen.
Okay, I can see now.
Okay. So, hi everybody, good morning. I'm Bhavna Sankam. I'll be walking you through the weather integration. So today we'll discuss the high-level system architecture. We'll go through the interface overview and how the data flow occurs between the zones, and some of the configurable functionalities available for the interface. Um, Use cases and sorry, uh, was there a question? Sorry, I didn't get what you were saying. Sorry, Mehdi, was there a question?
Sorry, Bhavana, we have a problem about monitor. Can you yeah, can you repeat?
Okay, I'll continue. Sorry. Just let me know if you have any questions. Just stop me and feel free to ask me any questions if you have. Okay, we'll go through the data flow and the interface configuration, some of the use cases and error scenarios that we encountered during the data transitions, and the network model requirements that is precondition to enable this weather adapter. So, from a high level architectural perspective, so all the integration adapters are deployed in the DMZ zone. So, this ensures a safe separation between the external system and the core. So, as we can see here, the uh, corporate system, which is the external utility systems, and the core or the production environment is separated by the DMZ zone, so which is where all the integration adapters are hosted. So there's no direct communication between the external system and the production environment. So this is I mean, since the core is a high security environment and where the all the ADMS applications operate, so we are not directly transferring any data directly into the feeding any data, be it weather data or AMI data. We're not feeding it directly into the core. We Everything goes via the DMZ environment. So, so each adapter is a separate process in the DMZ integration. So here's the weather adapter, one of the adapters that is available. So all the adapters are hosted as a Windows service, and each and the all the adapters follow a SIM-based model and use the IEC compliant SOAP services and messaging. So I'll just go to the system quickly and show you how they are hosted exactly. So here I'm launched the NMC. So this is the DMS integration. So under this DMS integration, if we go to the processes, we can see that all the enabled processes are hosted. So this is our weather adapter, which is also called as WDI adapter in the system. So this is the process ID 7332 is the process ID. So this is where all the adapters are hosted and we can see all the adapters. Okay. So this is the high level architectural overview of the integrations and the adapters. So coming to the weather integration, our weather adapter exposes, either SOAP based, we also expose REST interface as well. So which enables the external system to update the actual weather data, which is the real time weather data, and also the forecast data. So update actual weather data is invoked when we want to update the real-time weather data for any particular weather region, and we need to invoke the forecast weather data if we want to update the forecast values. So each adapter has its own dedicated log file, which is located in this path. So I'll show you where the log files are located. Data versus. It's under the DMS integration. So all the adapter logs are located here. Each adapter has a normal log file and a sensitive log file. So sensitive log file contains a bit sensitive information related to the service URLs that are available, and and all the proxy related communication related, which are actually sensitive and not to be shared. And the normal log file uh, carries all the transactions that are and errors that are happening. So if any message is received, that is captured, all the success scenarios and the errors are all, everything is captured inside this log file. Okay. So so the weather adapter is hosted. So once it's available, let's understand the data flow. So when the adapter receives any request, it handles in a multi-stage process to ensure data accuracy. So when the adapter receives a data from the weather source from the external systems, it first validates the incoming message. So it first checks that the incoming JSON message or the SOAP message payload has the correct definition, correct API definitions that we are already defined. So it also confirms the structure if it matches the SIM defined schema. So it also ensures that all the mandatory fields are present. So for example, if we want to update the weather region, so the weather region MRID or the weather region should be defined, or it should exist in the model. So if it does not exist, the adapter will throw an error. So the measurement types also must be supported. There is a list of supported measurement types available as part of the baseline. So I think I've already seen that these are the measurement types that are supported. I think there are 10. So these are supported. So anything that comes in apart from this, the adapter will not support, and it will throw an error. And also the base and the timestamps must be valid. It should not be in the future, or it should not be missing. And if any validation fails, the adapter generates a fault response back to the caller. And all the detailed entries raised in the adapter log. So we can quickly see a small demo here. So this is actually a sample payload that we have created in the system. So this is the actual structure of the payload. It has the header and the payload. This is according to the XSD defined. So this is the east weather region which is available in our system, and this is humidity is the supported measurement type, and this is the timestamp, and this is a value and the measurement quality. So for example, if we send some invalid data, it will throw an error saying that the weather region could not be found in the system. So everything is sent back to the caller saying that it's not valid. So if we sent a valid request, if the external system sends a valid request, the adapter validates all the payload and it says okay. And accordingly, the signal is applied into the value is applied into the DMD. Let me show you that. Yeah, I think this is the one which was updated, the humidity and the weather data. So once the validation is passed, the values are applied into the model and the changes are actually visible in the associated signals that are available. So if we want, we can quickly go through the use cases and error scenarios that we can encounter in these transactions. So we should follow this invalid. If the verb is invalid, it will throw an invalid verb error message. So everything should follow the definition mentioned here. So the baseline definition mentioned here, we should not change that. So similarly, invalid noun should not be changed. It should be as per definition. So mandatory element missing. We do have some mandatory elements defined in the payload. So any missing elements will be uh, sent as an error. So as we discussed, invalid weather region ID. So weather region ID should be available and be valid inside the model. So missing weather region, the weather region should be included inside the payload, and the measurement type should also be valid. And the timestamp should be the current timestamp. It should not be future. It should not be in the past. It should be the current timestamp. And the timestamp is a mandatory field, so we should not skip updating that. And invalid weather data out of range. So there are some values that are out of range that can be given out of range. So that should be taken care of. So the invalid measurement value. So quality, I think there's defined enums for this quality. This should either be in good or questionable. So if anything other than that will be thrown as an error. So this is for the forecast. So missing analog values. So this is also, if we are missing any analog values for a particular region, this is sent as an error. So these are the usual error scenarios or use cases that we can encounter during the message transactions. Um, any questions so far?
So I just see your demonstrate for the communication between your I don't know how to call that Oasis to core system, right? On from Oasis to like weather source. I don't know yet, but it's just a specific value only, right?
Is this
So
the one
what-
you're talking about?
Yeah. I have a little bit confused from your message. Can you go back to the Oasis?
The server, I think, yeah, server.
Server?
Yeah.
So
The NMC? Okay.
Oasis. So this service you can create like adapter to receive the weather data or something like that, right?
Yes, yes, that's right. That's right. So this adapter exposes the SOAP web service, and that particular web service should be invoked to get the messages in.
Okay, after receive the data, so after the validation, they will like transfer the data to the core system, right?
It will, yeah, the adapter will validate all the data.
And transfer to the core system like real-time system, right?
Yes, yes.
Mhm. So for your demonstration, I just see like request for one data point, for example, humidity for value around 90, right? Just one value. So
Yeah,
what if
I added for one value. So here we can add multiple measurements here. So we can just copy paste, repeat this particular part and add multiple measurements for temperature, for sunrise, sunset, for insolation, for multiple measurement types. We can add this one.
okay, for the show up UI is this application represent for like weather source, right?
Yeah, weather source, yes.
So what if our weather data just like a 5 only, so we cannot provide any soft service like this, so how could we solve it? Because the data from the weather we buy from other companies, they just give us like Excel 5 or maybe CSV 5 only.
Yeah, I think in this case, because of yeah, by our scope of work, we will provide we obligated to provide the baseline indication, which is this adapter. So as I discussed with many, maybe once you get the data from other department or other company, you have to convert your data to this payload and then put in the SOAP UI and push to our system through the baseline integration.
But we have to do like every day.
Not manually, but what, can you explain other companies how they do that? Yeah, this is for like, yeah, once they want to try test system, so they put it here, but other companies develop something that it can sense it every, I don't know, 1 hour, every 15 minutes. How often you get that data? Do you get like once a day or?
Once a
Yeah,
week.
forecast maybe we can send it once a day, and the real time is actually real time. So we need to configure that at the. I mean, it's the business should decide how frequently that should send, so that the calculations would not affect.
Yeah, so two things. One is, okay, other companies, they have some kind of like developing some company, sorry, the software to connect to our integration service and send this payload. Can you explain that experience from other companies if you have more information? You
Sorry.
go, if you go to do your presentation. Yeah. Just, I don't know if you understood our question.
No, sorry, Mehdi.
Alright,
So
can you go to presentation, just your presentation?
yeah.
Okay, so this one on the left-hand side, it says corporate, so you get some information, whatever it is, CSV, blah, blah. This system makes that payload and connects to our integration adapter and sends that payload. And so the frequency and all of this we can discuss, but I think your question is here from corporate, about one, they get like a CSV file, for example. They need to write some kind of like or a piece of software that makes it similar to the XML that Bawana was showing. And then you send that XML to us, right? With some port, we need to define which port, for example, TCP, is it TCP or what is it? So maybe some configuration about
It's
that
not
we will explain.
TCP is it's a HTTPS. It's SSL. We need to configure the certificates. We'll go through the communication part and the web service configuration part. But as I said, so the adapter needs the XML format, so we cannot accept a CSV. It should be converted into the accepted payload before it reaches the adapter, so it should be converted at the business end.
Yes, because I contract with the other company for the where the data they just give us like that. So if you want like a swap service, something that you can read or request the data from your integration server, maybe I have to discuss with them and with our manager first. So yeah, I have to discuss.
Yeah. Okay.
And yeah, you already know that our network is very sensitive with the internet. So if they want to build some service like swap, they have to connect to the internet, and we have to connect to the internet to get those data. So our policy does not allow so far. So that's really.
Okay, so this one doesn't allow you to connect to another
Yes.
system?
Yes.
It doesn't be internet, it could be, I don't know, blue metrology, they have some.
So if they want like build like private listener for just provide for this service from us only, they have to build like private infrastructure for the network, and this costs a lot of budget. Yeah. They usually use the internet. Yeah. As my like experience, they usually use internet to provide those data.
Yeah, so I think Bhavana was explaining this, we have this demilitarized zone and the production. So this one, for example, you get the SCADA and users are here. There are some firewall rules between these, so it doesn't allow to, communication. Yeah, it's kind of like isolates the zone. And then this is other utility, they can connect directly to the prod. So they go to this demilitarized zone.
I understand what you understand.
But yeah, I think your problem is kind of from this side.
Our policy like we cannot connect like physical devices like we don't have any physical connection from those server to the internet. Not just for fiber.
Our system are completely isolated from the internet, so.
Is
Because I mean the thing that safe for us to override the system.
Is it possible that you make something in your system, kind of create another server, and you just receive the just manually put the Excel file into that server and make some code to convert that server to
Swap service.
yeah to XML and send to our service.
Well, that
That
would
is
be,
another way.
I mean, that will be a manual, which would require a lot of, I mean, definitely we can, host it in the SOAP UI and, generate an XML and send it to the system, but that would require a lot of manual efforts on your end. When it goes to production, it would require a manual efforts. You can definitely use it. So this is just a SOAP UI. It's already available. You can just create this XML in this format. It's not a complex thing. So you can just change this from the CSV or whatever you are getting and send it, and it will be reflected in the signals in the model. So, but yeah, as I said, it's not a automatic process.
This was for one value. I think you have a plan, Bhavana, to show a sample for forecast when you send data in future. Is it this? You have
Yeah,
that?
I do have the
Alright.
request for the forecast as well. So I think Maybe we did it for a lot of values here. So this is the forecast data. Me and Mehdi has populated this for I think lot of points. So this is for the West region. This is for one of the measurement types, humidity, analog values, and so these are the analog values. So
Yeah,
this is for every 1 hour. This is the starting timestamp, and after that it will calculate for every 1 hour by default. So I think there are a lot of points here. Can't really.
And in the software also, you can show the DMV that it goes through a signal, and that signal will show you how reduced by forecast.
Okay, so
But I think the other problem is, if you get it only once big, maybe for forecast, it's good, but does the weather for changes, right? So forecast changes every few days, like at least probably maybe you need to make it more frequent, once a day or something. I don't know.
yeah, that's why I have to think about the automatic solution.
Yeah. Yeah, manual. Yeah.
Okay, I have to discuss with my manager first.
Yeah, especially the real for like for forecast, you can say, okay, this is next 14 days, next 7 days, all right? But you will be okay, so if you even do it once a day. But for real time, for example, if you want to calculate solar, as we said, you don't have measurements. So you want to see what is the solar at this moment. Normally other customers, they do it every hour or every 15 minutes, something like that. It needs to be close to real time. And what I was saying, if you, for example, do it once a day, then it's at that point, so it doesn't update, you need to update it every like minimum, I would say half an hour or 1 hour or something like this.
Yeah, it's basically 1 hour, but we can adjust this in the configuration to be it to be 15 minutes as well. So
No, I meant the real time one. The
real time. Okay.
How often you update that? I think one.
I mean, that's
problem-
on the business to decide, maybe. I
Decide,
mean, we're
yes,
not,
yes, yes.
we don't have any control
Yeah,
over it. It's the endpoint invoking,
Yeah.
business invoking the endpoint. Yeah.
Yeah, I'm just talking about like the use of that for the ADMS system, so you would probably need that. Okay.
It's just, please just continue and I will discuss this problem later with my manager.
Okay, no worries. I'll send you the sample payloads as well. You can refer to it. As I said, it's not really complex to create this manually and send it without connecting to the without actually hosting this. Okay. So I'll quickly go through the interface configuration. So every adapter has the below mentioned configuration files. So let's go through them in detail. So first one is the registry configuration file. So this is the primary configuration file of the integration adapter. So this one is located at Schneider Electric Data Oasis registry. So all the adapters configuration files are available here. So this is WDI. Let's open that. So this is so it contains data required for the adapter initialization and startup, as well as references to additional configuration files. So additionally, it also contains process related parameters which can enable small modifications. So all these things are, are required to start up the adapter. We will not be changing any of these values as such. So these are the used units that is already configured. Will not be touching that as well. And these are the minimum and maximum values for the signals. So this is the maximum for temperature. For every measurement type, it's also defined here. Minimum temperature is -60. Feels like wind speed, humidity, everything is configured here. And it's just these few values that we can configure. So if we take a look at this one, weather region identifier. So this one is actually how we will identify the weather region. So by default, it is name, but also we can identify it by custom ID. So what I mean is, in the payload, in the MRID section, we will be sending the name if this is configured as IDOBJ name. So if it is configured as custom ID, so if we want to send it as custom ID, so we need to change this to custom ID and then send the same in the payload as well. So this is just a that's an option to choose what suits the best for your needs. So this is the time span for forecast measurements. So this is in seconds, which means this is 1 hour. So we can also adjust it to like the smallest possible value, like 15 minutes or 30 minutes. So based on our needs and how the ADMS applications, how we expect them to calculate, based on that we can modify this. But by default, this is 1 hour. So this is a date time format that we will not be using that as well. And there's an additional functionality that is available, which is called as stale um, weather data staling. So by default, this feature is disabled. If we want to use this, we can make this to true and start using that. So this is only for actual signal values. So through this functionality, so the signal quality can be set to questionable. So if the updates were not received more than the configurable time period, so the signal will be set as stale. So this is used to so this is a stale time trigger. So it checks if the updates were received every 30 minutes. So this is also configurable. And stale time interval. So if these signals updates were not received for more than 1 hour, it will set the signal to questionable or stale. Yeah. This is the additional functionality that is available for the um, actual signal, I mean the real time signals, not for the forecast. So if we want to use that, we can also enable that here and use it for better signal quality. So these are the adjustments that we can do here. And coming to the next configuration, this is a web service configuration. So this is located under ADMS configuration. WDI web service configuration. So here we can define all the service URLs. The main thing is the service URL that we can define, and the authentication type. If we want to connect to the external system, we can use the two-way authentication or one-way authentication, SSL authentication, and we can put in the certificate name. So these are the things that we configure if we want to connect to the external weather data or the external utility systems. So the rest all are baseline, so we won't be changing that. So this is for the receive actual data, which is the real-time data, and the other one is for the receive forecast data. So the same thing is applicable. So we can change the service URL, the endpoint URL, authentication type, and the service certificate name. Okay. So the other configuration we have is the error configuration file. So this is also located under the same location. So error configuration file just basically lists all the use cases and error scenarios that we have already discussed. So this invalid message, payload is missing, all the possible errors that can occur in the payload. So everything is listed here, value out of range, invalid quality, all these things are listed here in this configuration file. So we can change the severity here. Only thing we can change is the severity here. It can be critical, warning, or fatal. So we can change this severity if we want to, but it's not recommended to change this. But it's just for our reference. What are the error scenarios that we can have? So lastly, these are the network model requirements that we need. So applications require both the current, actual, and the forecast weather data measurements. So the actual weather data is modeled with an analog signal type, and the weather forecast data is modeled using an array signal type. So in the network model, weather data is modeled using measurements associated to a weather region objects, which are associated to one or more substations. So creation of weather regions, association of substations to them, and the definition of weather data measurements is done using the network builder. So finally, before integrating with live data, network builder we must define the weather regions and associate those regions to the substations, and create analog and array signals for all measurement types. So these are the preconditions that we would need to enable the weather region, weather adapter. So without this, we cannot send in the data.
So just a question, on your case, we're gonna use one weather region, right? Because it's gonna be one.
I mean, we can define any number of
Any number, but for
weather
this
region.
project, yeah, for this project.
Yeah.
we're gonna use-
Yeah, one which should be associated to substations, and the signals must be available for that. So these are the configurable functionalities that we have already discussed. So the weather data stalling, yeah, this is the one we can use it for setting the signal quality to stale. So identification of weather regions. So this is also customizable. We can identify it using a name or a custom ID. And the forecast time interval. So by default, it's 1 hour, but we can change this to any time interval that we want to. So I mean, that's all with respect to this particular in adapter.
Đi qua mở giùm cái máy sơ bộ cho.
Could you please go to DMD? I just wanted go to DMD and show the array signal to wanted them to see how the array signal would look like in the DMD.
Okay.
You already saw the first one, right? That was temperature. Okay, I think that those are, yeah. Double click that. Yeah. Yeah, so if this array signal, you see here the signal says weather forecast. Right. When you see this weather signal, that's forecast. So it shows the array in feature. This is irradiation solar, right? So for example, then we basically the payload that one was showing, we put some sample, right? So it starts at this like morning, goes up, goes to maximum, goes down, and it could fluctuate here as you see. So for example, there might be cloud here. So if it's full sunny, it's gonna be like this, and then yeah. So you get this data from forecasts.
So could you show like how to like do the configuration for this point, like create this point and how to put the address to connect to the iteration server or something like that?
Yeah, so it's can you close this? You have it already open on the left side, so east region, I think, I don't know if it's east region or west region, either way. Can you open that, expand that, please? And it shows where it is, but like I wanted to expand that, shows the signals under
Okay.
that. Can we go back to that module browser? So you expand that, yeah, see, this is like under your root, we define this region, like where we had two regions, and then under that, so you create these signals. And if you go a bit further down, so these are many signals, but like you don't need all of them. Some of them look a little bit different, the icon is a bit down.
It should be in WD.
Yeah, so
and
this one, for example, you see the
WF.
size, yeah.
Yeah,
Okay, this one that it shows like, these are forecast signals. These ones, so when you go to the builder, you can define just normal signals, and these are array signals, that was. You just double click that as well, that's the one that you were showing, that's feel like, yeah. I don't know if you can double click that or property, yeah. Yeah, so this one is all.
This is also you can use the array signal and it's specific for weather data.
For forecast, yeah. So,
Forecast.
so the difference here, you see, it says maximum number of points, so that's 336, so is like number of samples. Like, let's say each hour one is 24 samples for one day, and like, I think we calculate 14 days, yeah, 14 days, yeah, exactly. This is for 2 weeks, because normally we forecast, we can't do up to 4. It doesn't need to use all of it, but like, that's the way it works. And then you, for each substation, you make a reference to the weather region.
Okay, so for one station, we just like can create just one point like this, like community, you speak in direction, just one point, and we have
2 point, one for vector data, another one for vector
the forecast.
forecast, yeah.
Weather
The
forecast.
three things analog, sorry. Maybe you can see we have two temperature. This one is analog, sorry. This one is for array, array is for vector forecast.
Okay, and when we use the name of the station and put to the iteration service, they will know and they will put the data directly to the like humidity, temperature.
Exactly, so
Yeah.
I think when she was showing this west weather region, so this name.
Okay.
In the message, you send this message and then you say humidity. This name doesn't matter, the type of this matters. So like, for example, this is the forecast, but if you go a little bit down on the right side, Bawana, no, okay, sorry. We closed it, but okay, can you just open it again? There is a measurement type here, so here. That measurement type is, for example, feels like is like a temperature, but if you go to in humidity, it might show humidity. So that's
That
the
time is the,
in the payload you would send this.
okay.
Yeah.
So the name is not really important, but that type is important, right?
Yeah, for signals, yes. But for the actual weather regions, so the name is important. So okay. And can you just, sorry, go on, can you just open one substation, open Montana Sky, for example, as a,
Sorry, which one? Montana. Okay.
yeah, can you open Montana Sky, for example? Substation. All right. And right click and show the properties. All right, if you show all, like, yeah. So there should be a property called weather region. If you go down a little bit. Too much. Up a little bit. It's under info. Up.
Ah,
Yeah. So this attribute, it says this substation is to that west region. So maybe another substation says, I'm west region. So you here you define how many substations belong to that weather region.
So what's the maximum point that can store in this point that weather forecast?
It's not limited, but I think we don't normally do for 14 days. Normally it doesn't make much sense more than 14 days. So because your forecast is not accurate, so our forecast uses normally 8 days, but we can change that to make it 14 days. We just put as a placeholder for 14 days. We don't need all of it.
Ví dụ thời tiết sàn phải mua nhưng mà bây giờ
Sao nó vô Canada?
cái này em nói là em báo là em
Có cái gì?
có thì sao chạy.
Ở đó cái này nó quan trọng. Không phải chạm lắm.
So when we push the new data from the iteration service, they like replace the old point by the new point, right?
New value.
Yes, yes, it will replace the value.
Đúng rồi. Cái số 40 lần đó. Rồi chặn số nhắn được tên của bắt đi. Đó là nó sẽ móc bớt như thế.
But what if like we buy some services for the weather and they just provide the solar service also, but different, a little bit different format. So how could we like change the format between the weather supplier data and your iteration service? Like also, but they have some more like specific data for their service, and maybe when they push the data into your iteration service, maybe they will cause some error. So yeah, how could we fix it? Like
So, okay, the third party that you get the data from,
maybe like open weather or something like that.
yeah. So it needs to be adopted to the XML that we have, and all those messages that Moana was explaining is for troubleshooting. So if you develop something and at the beginning you see, okay, I send a message, I get a reply. I think she was showing one example that it was wrong and it shows something wrong. You troubleshoot and fix it.
Yeah, basically based on my experience in project in Thailand, big project, customer bought the weather forecast data from third party. Basically the third party, they provide the API for us to connect. So we have to do some kind of the customization to match from their API to our API. Yeah.
Or you have to do like customization.
Yeah. But that is what we did not expect in this project. But yeah, in the future, if you kind of buy the weather forecast data from third party. Our API support that. We might need to do some customization.
Yeah, because I think you should like have some familiar format for third party like for open weather or something big like that because they just give one format and you have to follow them.
Yeah, but basically from my experience in the beginning from Big Green Project, they choose several, I mean, they have many choice of weather forecast provider and each weather forecast provider, they provide different API. So it depends on which weather forecast provider that you choose. So the API will be developed as per that weather forecast.
And like each company is different. It's not like everybody use open AI. So for example, in Australia, they have a Bureau of Meteorology, which has a more accurate data that, you know, the one that is globally done because they have their own weather stations. And it's not using, for example, temperature. They measure accurately on site and they have their own forecast and stuff. So each company in the world, they connect to different systems. And normally a company hire, I'm just saying that the best way to do this, instead of changing our software, is to develop it's not actually very kind of heavyweight. I would say it's a kind of a weight, like they normally have a contract with some integration companies that they get that message as input and they send as output. And those integration companies, they look after even like what you said, okay, we cannot do, I don't know, like connect to the internet, but if there is some other way to do that, to firewall, to design something, they also do that. So that's my experience as well.
Yeah. I just thinking about another choice that we saw in PA. They use the ESB to do the conversion. Yeah, the enterprise bus to do the conversion of the data. Yeah, that is another choice. If you are, if in event you have the ESB, so that could be used as well because of normally the job of ESB is to convert the data from one system to be compatible with another system. Yeah.
Actually, in my experience, ESB is just like business bus bar for network only. It's not like some kind of service. You have to build your specific service, like create more server and receive the CSV file and convert to short message and send it to like your integration service through the ESB bus.
Yeah, but in case of PA, they use the ESB. Let's say our ADMS support. Mainly we prefer to use the SOAP, right? But in the other system like the SAP, they use the other technology. So ESB convert that message from that technology to SOAP.
But they have to like write more services, small services inside the ESB.
Yeah.
That's
But
one.
we don't have like a software engineer to do that. So
Yeah, that's why. Yeah, other companies I work with, like in Australia, they don't do software themselves. They hire like another company. They do integration for them. So that like a small project, I think it would be for this one. But like maybe if in future you want to invest more in this software and you develop, for example, we were talking AMI or whatever, you're gonna have the same story. So it's gonna be you need to connect to another system, right? So
here's about AMI. I think it's quite the same with the weather because in after they receive the data from AMI system, they just put a table in SQL server, like how to say that after receive the data from Meta, they store in the SQL server, and they just synchronize the table for us to our SQL server. So I just see the table and the data inside the table. So how could I collect the data to push to in like your interaction server? That's also a big problem.
It's yeah. Anyway, I mean, so in this project we provide a baseline adapter for AMI. However, I have two cases in customer in Thailand, Big Grim and PA. In Big Grim, they have the same concept as yours. So they put the data into the SQL server. So we develop something to kind of query the data from SQL server. Yeah, like it's not baseline integration, but just kind of the customization to get the data from AMI server. Yeah, to query the
Or if you can do so, because maybe we can push the weather data into SQL server also.
but no, not that is customization that I told you. That is the customization, not our baseline.
Yeah.
However, actually in PA, they because of AMI system, it's not only the data, they can do something else for kind of OMS and so on. So they request to do the API integration so that AMI system can send the real-time status of the meter. The meter can be the power on, power off. So it can send the real-time status from the meter to ADMS as well. Yeah.
Okay.
So it depends. Yeah.
Oh, well, this technology of this one, you said it's HPTPS, yes?
Yeah, yes, that's right.
Uh,
So Pankaj, do you think that we should, Schneider should offer a customization to convert the CSV and feed it into the ADMS for the weather data?
It's nothing to.
It's to be honest, it's not in the scope at this moment. So
Okay.
I think it's not a big job for customer to do even manually or
Manually is not possible. You need to send it every hour.
yeah.
You can say that, right? Like,
But because of they have only once a week, they receive the weather forecast only once a week.
no,
right?
I was saying that for it's real time,
Real-time data, yeah.
data and less than 1 hour. I mean, it's up to, I mean, then they, if they don't have weather data, they cannot use forecast, right? They don't want to use forecast then. But if they want to use forecast and all of this, they need to get every 1 hour.
Yeah,
At least, yeah.
at least for real-time data.
Yeah,
Yeah.
yeah.
So maybe we Mr. Fuchs, so to be frankly speaking with you, our obligation is to provide the baseline indication like this. But I'm not sure what your expectation and maybe you can know this, discuss internally what you can do first, and then we discuss in the weekly meeting with Fra and
Mhm.
live again.
Yeah, because there are other things, like they cannot get access to internet. That's another, they need to put some kind of
Some
whatever
kind,
infrastructure in place to connect the public
Yeah,
data.
like this
Yeah.
this some like information from us and yeah,
Yeah.
send to you for just
But at least you know what what we expect from your side and what we normally baseline what our baseline is. Yeah.
Okay. Got that. Yeah. So we'll wait for you to discuss internally and get back to us. So that's all I had from my end regarding this interface.
Is
Any
there-
question for her? Mr. Cook? No question.
Okay.
Okay, thanks, Moana.
Okay, no worries. Thank you. Just email me if you have anything. Thank you.
All right.
Bye.
Thank you. So basically, this is our baseline and our requirement to receive your weather forecast data and weather real-time weather data. But yeah, we can discuss further how you can provide this to our integration. Yeah.
You will use your microphone.
Everybody can hear. I think maybe we can use my microphone now.
Okay.
Or in line. So most of our customers, they don't use AMI data for a state estimation and stuff like that. So it's not mandatory. If you can provide it, it's good to have, but not mandatory. For these applications that we are working. So if you're talking about, okay, DERMS and blah, blah, at this stage, it's not like quite mandatory.
Yes, but I just showed you our requirement for the project. So how could we change because AMI is one of the model, right? Model in this project.
To be frankly speaking with you, AMI is part of the project, but from the scope of work of Schneider at this moment, the AMI we provide only adapter without any integration. I mean, we provide the adapter.
License.
That license.
Yeah.
Yeah. That license.
Yes, but yeah, because I don't know what's the responsibility of the green infra, but in a contract, they have to I just showed you yesterday, right?
Yeah. I see that.
They have to build some model to convert the data from our MPMS, especially for AMI data. So I don't know
That is yeah. That is. I would say I already list this to FRA and even
yes, maybe they will write some service or software to convert it because I think it could be right because
It
it's
could
just
be,
a
yeah.
service.
Yeah. But for AMI, if you use our baseline indication, we can provide you the function specification of the AMI integration. Yeah.
Because it's also the software or API.
API.
API, okay. API, but the same iteration server, right? Inside the iteration server.
Yeah. I think in the same server, right?
API.
API integration, AMI integration is the same server as weather integration, right?
Yeah, it could be on the same
Yeah.
server. Yeah, it's going to be the same integration set. Okay. Then we go to the next topic.
So you want to write something down for
Yeah, yeah.
discussion later? It's okay. Take your time and.
Yeah.
Whenever you're ready, let us know.
I understood we have some. Okay, some this kind of gray area. Yeah.
Okay, so this is, I'm just sharing the agenda. So yesterday, I think we kind of, we went a bit faster than we expected, and we could manage to finish a SCADA half day. And then, so some of this topic that I was planning for today was covered actually yesterday. I showed the tracing and the coloring, load flow, and a state estimation yesterday. If you want to see something from that, a quick one, I can still demonstrate and repeat, or if you have a question, what do you think? Do I need to just, are you familiar with this?
Actually, I can watch the old video. So
Yeah,
I
okay.
think, yeah.
Yeah, and probably Farhan also explained many things. I was mainly focusing, okay, what is the configuration? What is this attribute? What is this? I was more in details, probably what Farhan showed, but okay. And you have the presentation as well, and the functional specification if you need. Okay, so then this, I go to the next day. So the sessions we're gonna have is about introduction to DERMS, their awareness and control, and hosting capacity, and active network management, and what flexibility we'll discuss it this afternoon. Okay, so I go first with this presentation. Can you see the presentation in your laptop? Yeah, okay, you got it. Okay, so this one is, okay, terms awareness and control. These are a bit high level. Again, I start from high level to explain what terms kind of modules are together. I think there's, I put there, let me just quickly fix that. Sorry. Okay. So, all right. So the first thing when we model started for the DER, we model DER basically elements in the system, and we want to see how is the impact on the rest of things. For example, on load flow or state estimation and all that. Then we have another modules to just monitor the status of DER, where they are, how much they contribute, how much they, for example, produce energy or consume energy. And then DR control, which is like for those devices, manually operators can go and find them, separate the rest of the elements, and send some controls. And sometimes you can send to multiple elements at the same time. Yesterday, Sunia was explaining to you like how you can configure this in like the control sequence or interlock to send multiple commands, but DR has its own because you can have like multiple set points, so it has its own. You can send like multiple controls as well. So that's the awareness. And then look ahead. I put look ahead there because look ahead also shows the information, but in future. So it uses the weather forecast and the forecast itself machine, which we gonna explain on the other day. So it also gives you visibility of like what will happen in future. The first three is real time. So then we have this module as for planning. So planning means, okay, you have a network already. You want to see in, for example, in next 3 years, your DER concentration will be changed. So instead of, for example, you have one solar panel every 10 house, in like 2 years, 3 years from now, instead of one house, you might have 3 houses. So you want to know how your network basically is ready for that. Does it create constraints? So it can, right? And customer connection, like this one have like at one customer, maybe a big solar or a big PBS or something like that to see the impact again for kind of like planning purposes. Then we have like some applications. These are more applications that tries to mitigate constraints that we have. Let's say because of too much solar, you have too much reverse flow, or even it could overload a system in certain situation. You want to use the battery to mitigate that overload, for example, produce energy or curtail solar. I think we have curtailment, we have managing that. So this active network model, active network management does that. And also this one, we also could mitigate things like voltage, regulate voltages, and could use conventional assets that you already have in your network, such as voltage regulator on transformer for capacity. So these are high level, right? So okay, what data we need for it? Model based, I was explaining yesterday when we say model based in our applications means it uses load flow and a state estimation in the background somehow. Because of that, anything we need for load flow and state estimation would be there. More specifically, probably the Thevenin equivalent, maybe not quite needed, but like impedance we discussed yesterday, transformer we discussed yesterday. These switches, you need to model where they are. Now you could have generators. If you have a big generator, like a synchronous generator, maybe you will have more data on that one to see what is the impact of that, and load profile and a state of the network we said yesterday. All right, for DERMS data, what we need? Type of DR, which is clear, like, you know, like we have a list of types, for example. It could be also flexible load. Sometimes in some companies, they provide a controlled load. For example, they had hot water at home. They allow the utility to stop that hot water or air condition, so they can actually manage the load. So it's not just something like battery or solar, but also something that companies are on contract they can control. So flexible load is one of them. So for these DRs, we always need like, okay, how much is the rated? But there are some more specific data for each type. For example, for battery, we need the capacity of that battery. How much is the charging rate? How much is the discharging rate? And like, how much is charged, like in percentage or kilowatt? So I didn't put all the data, but yeah, so we have in the documents, we have everything that is needed. So, and we discussed about weather already and the SCADA. So for SCADA, we need measurements and comment and set point, right? So maybe one is set point, I think we covered yesterday. These are elements that is needed, okay? All right, so then maybe I switch to the software. Let me see if my software is connected. All right, so this is an area that maybe I just maybe show more. So this is this mountainized sky.
Here, if you go to the top, so you have like a section for DERMS, and you can start from the left. So DR browser. This just tells you where the DRs are, either monitored or not monitored, doesn't matter. So here, this hierarchy, so this was like the whole model. So it says 1,575 DRs we have in the system, and you see the list here. I just maybe show a few of them, and you can basically see this one here, so you can select and go to your network model, and it puts this kind of like icon here to show you the one that you selected. So sorry, let me close this. Yeah, so this DR summary, you can select multiple, actually. You can select this one and show it there. So if you zoom out, you can see the one that you selected somehow. Okay. I probably explain a few of them. So this is fault contribution. Normally, I think you don't have this in your modules, but like it can use for fault calculation. So you can pay per person. So yeah, we have that module separately, but yeah. And the technology type. So that's the one that we said. So technology type. So you can filter, for example, here, I want based on technology. Type. So I just showed the list here. So you have battery, biomass, coal, CHP.
You are not sharing the.
I'm not sharing.
Because I don't see your.
Okay, sorry. Yeah, okay. Okay. Not sure. Shall I? Oh, maybe I have to stop the. Okay. Because PowerPoint is very specific. Sorry, that's good. You catch it. Okay, I think I don't need this. All right. So and then I have to put this one there. Stop sharing, and again share. All right.
Stop sharing and move DMD to this monitor.
Hmm?
You can stop sharing.
Mm-hmm.
Okay, and move your DMD to
No, I think
that monitor.
display. I just make it one.
Wow.
Oh, it's 10. Okay.
Duplicate.
Duplicate. Let me do duplicate. Changes. Or is it going to be very small? Sorry, guys.
And then you share screen again.
Can you see? Okay, so thanks for reminding me. Maybe I repeat. Okay, I repeat a little bit. So I was explaining that so if you open DMD, like you need to go to this DRM section, and then I was starting from the first one, DR browser, and then I was on the like showing everything here, and I just was saying that like each section, it shows how many elements of DR we have. So in total in this network, we have 1577, and we can browse on this one. But I was more explaining this part that, all right, so if I have element here, I can easily select this bulb, and it shows it and takes me to the display, and I can see more information there on the network. But okay, so these one, like we have a few fields here. So the first one is fault contribution, is for fault analysis, which we don't have it here. But the important one is this technology type. So I was using this filter to show you, okay, we can filter, for example, for different types, battery, biomass, compressed air. So these are defined. And if you don't know what exactly it is, you could, for example, put undefined or yeah. So if I, for example, I am interested for battery, let's say, and I see these are my batteries. So this number changes 32, and most of them are in this North America. And like I can just browse more by here, okay. And if I go for each of them, they have more different information. So of course it has the type, as we said, and if it don't need something, we just remove that. So for battery, so we said, okay, capacity. So this one is capacity kilowatt hour, right? It can go, but the charging power is 1,000 and discharging is 1,000. I go to the contract a bit later because we have like applications for that during A&M, but yeah, so these are, gives you some kind of like good information and insight for you to understand like where your assets are, and yeah, you can see them together. Okay. For solar, some of them, like for example, capacity and charging capacity only is for batteries. So this one remains empty, right? So because but what is important here is the solar is rated. Rated. So this rated power is 1,000. This is the critical, basically, attribute for this one, because when we have like it will be used for calculate how much power it would create. So all right, so that is DR summary. I think this is kind of like just for browsing and understanding where you have system. And then we have this DR overview report. This has a bit more information about compared to the other one. And let me just go to, and if you know exactly which feeder you want to go, so like any other things that we have, so you type the name of the feeder, for example, or the substation, and you just quickly go there and see what you have. So this one, these are solar, for example. Okay, so it's probably just is a whole house. It's a rooftop solar, and we have this icon for it. So the solar on this one is basically, let me just show you. So proper. Oh, okay, so we can have BR list for each area as well here. Yeah, so it has more than like for this one, you have more. So this solar, we can have properties. Okay, but this is on the house, right? So this is on the house. Okay. And then I have some predefined filter. So if I set to this, so it shows wind. So there is no wind on this one, so it shows nothing. But let's say I want to see the one we have contract. So this one has a contract. So the contract. So I hide this. I need to, sometimes the display are like hidden like this. You need to open it to see more information. This battery has contract. So this contract is for consumptions, for generation. You can have different contract with them. And you see, the full generation is 5,000, but the contract says at 5 a.m. we have 1,000 contract and 2,000 and blah blah. So it might be per different time of the day. So we have like one general and one. This is the contract that I was explaining. So for generation means battery generates to the system, consumes. Why we have both? Because of different problems that we might have on the system, we can utilize both contracts.
But it's just for like the power flow, or we can like automatically send a command to control the power generation from the contract.
Automatically or manual? Manual, you can send.
No, I mean automatically with the contract, we just define in the system, and the system, you know, that maybe for example at 5 a.m. they can like make the constraint to the battery that they cannot generate over 1,000 or something like that.
Yeah. So yeah. So yeah, you're right. So so this is means like we can force them to be below this if it's necessary. Not always. Like if it's basically we allow like the users to put up to 5,000. This is the capacity. So they have their battery can do 5,000, but we can tell them if there is some problem on the networks, the applications that I will talk about that later tonight, this afternoon, A&M. If they found some problem, it says, okay, limit that to these contracts, and we cannot limit them basically. Yeah, this contract will be used for when there is some problem. Okay. Let's see DR group. I just give you some examples of like different things. For example, if I just select DR group, I mean, we have the contract, but okay. This is prosumer. So this one, if I go and see where it is located. So this is like an area in the network. They have a multiple, basically DRs under this, but for us, it is like a DR group. So it's a group of DRs under that. We don't communicate. So what is the concept of DR group? We don't communicate with individual DR. So this controller, there's some controller or aggregator that actually controls them. We just talk to that master, saying, okay, you need to curtail this much. Inside that, it might have a solar, and it might decide to send the command to the solar, or it might have a battery, it might send the command. We just look at the net at that point. So it has a point where we just look at the net. So we don't care about what they're gonna do, but like how much we're gonna get from them and how much we're gonna send to them. Okay. And prosumer is like, okay, so like it can be generator or can be consumer. This one is, I think solar is clear, right? So I explained we have two types of solar. If you don't have measurements, we have rated and we use irradiation to calculate how much it would calculate. The battery, I think I already explained. Wind, maybe do we have wind? I don't know if you guys have wind as well, but it's similar to solar. You got, let me see. Yeah, we got a few of here. This is where it is, but okay. Maybe it's better. This is installed power, but okay, maybe it's better to show it here because I type. You also, for any of displays, if like this one already, you see we have this predefined one, you can create your own. So you can create your own. So you type whatever you want in your filter, and then you save it. I think, I'm not sure if we discussed it before, but you can call it Vint. You can call it private, shared, or global. Global means for all users. Private is just for you. Shared, you can share with few other users. And then when you select that, it appears here. And then if you press that star, it will display it here. So if I, for example, close this DR summary, all right, it's a DR browser. You see, it just appeared. It did not exist there. I quickly select that and find that information here. Okay. For the curves, for solar, for wind, we can have curve. Why? Because, you know, depends on, it might not be linear. So when the wind, for example, is very low, so it might not generate anything much. And then it might be a little bit linear, but then if the wind is more than like a certain limit, it can just be flat, or maybe stop after. If it's too much wind, if it's a typhoon or something, it might totally stop. So we can define the curve. So I don't know which one has a curve here. Let me find one, but yeah, in the network model, we can define that curve as well. Okay, so maybe I need to connect to the builder, show that curve as well. Okay. But this was like, these two are for information generally. So you can browse and get different data and show what is the flexibility. I think maybe here. The DR group. Oh, okay, so I forgot about this one. When it's DR group, so if you have okay, sorry, this was hidden. I forgot to explain. This is DR group, right? So as I was saying, like, let's say we have this DR group, it has like certain element under it. So this one is just the battery fleet. So means that you have 4 battery in one, but we communicate with just one of them. And this one is combination of diesel, yeah, so this one, it shows also like a diagram, how much is wind, how much is diesel here. So yeah, this kind of like just for information in general, but like for us, is just, and this value here you see here, installed power, is the summation of like these elements there. So if the rated power, if you have this, for example, 15 members, right? So this is 15 DRs. Each of them has like a rated power, and it sums it up and shows it here. So 35 in total, we can have power 35 megawatts, right? So we can have that. So that's what it is, I think. All right. That's generally it. So I think for this one, I don't know if I have more information to share. Okay, let's close that one, and then we go to the next one, DR monitoring. These are like, what does that DR monitoring means? Now we get some data either from measurements or from calculation. Calculations like solar is used, for example, with irradiation, or wind used with whatever data we got from winds, and we get this overview. These are for everything, right? As like we showed. So, but let me just go to, for example, one specific area. You can see automatically everything changes when we go like and show each of them. Maybe I start from here. So this is total DR production at that moment, like is 12,000 megawatt kilowatts, so 12 megawatts. And this is injection and consumption. So this delta should be kind of like matching. And here, dispatchable and non-dispatchable. What is dispatchable? For each element, if we have control, like as a utility, we have to control it to reduce or increase it is dispatchable. If it's basically there's some attributes that we define, and based on that, so these are green is yeah, and non-dispatchable is like we cannot control. So this one is for generating unit, is for battery. So for battery, we have these specific things, right? Okay, so apart from like total, it says how much charging we have. So for all of this, so there are, let's say, we can go to details and see how many are they, but in total, we have 47 percent, which is, if you hover on it, it says how much is in kilowatt hour reserve you have. And then if we go to the right, so this one probably I need to expand for the DR group, but this is critical point. We saw this yesterday for violations, voltage violations as well, but like you could see kind of like where is the problems and pinpoints on the system, and you can basically locate them. And the color code is, okay, green is good, and this is under probably some percentage, it's a bit high, and I guess, and the red is like out of that range. There is some shortcuts for event summary and alarm summary, and it just does it for this, for example, North America related to DR. So, and this is the forecast. So let's say I go to, I don't know, like this one. You see all the data changes, and it shows the forecast and everything for that one, for that period of the time. Production, injection, consumption. So you can just unselect and see what is exactly happening. So there is here, probably you can see it's some production happens later in the afternoon based on like this forecast. And then we got like, for this forecast, we have the extreme points. So extreme points here, it says at 11 p.m., 11 a.m., sorry, we have this minimum kilowatt. Or we have this maximum at 4 p.m. So I think we were sure seeing in the curve at 4 p.m. The production was increasing. So in that moment, we have this 1009, right? And the same for injections and consumptions. And this is again a shortcut. It takes us to look at another applications. It's just to be handy there. Then like if that was overview, now if I go to the details, it can show total again, and you can swap for each substation and feeder and transformer area. You can see all of this information. And if you select any of these, you notice that, okay, so here the DRs, like from that no other place is displayed. Okay, this one, this wind farm is producing. This one is producing, this one is not producing. And a state of, if you have a battery, for example, let's say the state of charge and everything will be displayed here. Maybe my batteries are somewhere else, but maybe we have some batteries here. Yeah, so this one, for example, the battery is 50%. Discharging, right? So this shows it is discharging right now. If it's charging like this one, it shows charging. It's kind of like a good way to know what happens in that substation, and like you can easily also locate the property like we do, and then see the forecast and stuff like that. And that was total, like it shows everything that if you're interested in a specific type, you just like select that one, and if you expand, you just like, yeah, you can just see like what's happening overview and this one. So yeah, this is total of this 350. So it only comes from this one. So if you expand, for example, 1, 2, 3, 3. So I select this one. So it's basically it's coming from this feeder TR01, all right? And you can navigate as well. So here too, so TR02. Yeah, so location here, it also shows the feeder name. Do you have any kind of question? The other thing is here, like if you see a signal here, that means it comes from SCADA. So that P minus 135, 350 is kind of like the set point, I guess. And this is coming from SCADA, and it might also do some calculations sometimes. If, for example, for solar, don't see this signal, that 90 is calculated from irradiation. Yeah, producing, okay. It also guesses that state of charge as well. If you, I don't know how accurate could it be, because you need a lot of good information for that. Do you want to see more about this? Like, you know, you want to understand like how things are done behind the scene, or anything? What is, for example, I can show you, for example, how this 90 is calculated if you're interested.
Actually, I think that they use the weather data from the station that you assign to the station, and like check the time and use the radiation multiply the power rate or something like that.
Exactly like that. So you got a rated value, and yes, yeah, it uses the measurements from that if you don't have them like from weather data. Okay. Yeah. Even for solar, you could have care, but normally we don't use care because solar is generally linear. There are some other kind of things that it uses. For example, the temperature. If the temperature is above, sorry, a certain value, the solar panel usually lose some efficiency. So if it's more than 25, it uses also temperature to reduce it. If your temperature is 35 or something, it just reduces that as well. So it is explained in the functional specification, but it's not just radiation, yeah. So it just could be multiple temperature as well. Okay. Okay. That is the ER monitoring. If you, I think we can go to the next one. But this one, okay, the first three was just data monitoring and control. So this one is control. Okay, so again, we have list of elements here. We have a new, basically compared to the other one, we have this new like a bar chart. So flexibility demand. So basically right now, the production of kilowatt is for when I selected this whole network is 566,000 kilowatts, right? So this is what we have. The two colors. So this is kind of like generation. So but it's flexibility. So they based on the data we get from the contracts and everything, we can increase generation by this far, which is like written here, 67,000. So and this green bar is kind of like generation. Generation is sometimes it could be demand reduction, as I was explaining to you, if you have controlled load. Also, because when we reduce the demand, it's similar to generation from this point of view. And generation, it could be also battery. So generate battery to inject the power. So yeah, you need to, when you think of demand flexibility, you need to think of, okay, it could be either of them. and this one is demand. So this is like think of like we can decrease this much of load from 4,000. And that is flexibility for Q or reactive power. And again, these are some control. Let me just go to one substation. Colorado. Okay, so this Colorado. Okay, when I just type it in, so this number all you see is changed because this is reflecting to what I have selected. So you see, it says 4 is connected already to the network. So four elements are connecting. And then if I select that, it shows why it was showing 4, because these are not producing. These one are only producing. You can see the elements there. There's nothing disconnected, so we cannot do much on that. So you could disconnect, like for example, you want to send all of these elements that we have on the Colorado. We just want to send in one command to disconnect. Like you see this one, it shows the list, and you could run it here, disconnect and disconnect it, or you could send it to a switching plan. And then switching plan, I think maybe I explained it a little bit because yesterday we talked about switching management as well. So you can just copy them here. So if so when you do this here, so you see automatically it just I created a switching plan with all of these operations. So what is the good about switching plan? You can just view and just go and to different places and just see what is happening there. And then if you don't want something to happen, that's just you can select even multiple and just like delete it or edit it or things like that. So and it could be done in future. So you can put some information here. For example, you can say, okay, DR control, for example, detail testing, for example. And then I just don't want to do it right now. And I just want to probably do it, I don't know, next Monday or next Tuesday at this time. And then save it. So, okay, you don't need to do it now, but we have a plan, let's say, switching plan. And then you can create some reports or stuff like this, but outage reports. So if like you disconnect, for example, some switches, if you open some switch, some customer would be impacted. In your case, probably we wouldn't import the customers list, but yeah, it could be done. And there are some extra information. Where is the coordination on the network? So you can just if you have crew to go. I was explaining to you yesterday that we have field crew, like we can tell them where is the coordinate and what is the address and stuff like this. But in your case, probably we wouldn't use this. Just want to just tell you how does it would duplex. And this is the life cycle. We saved it. Now, let's say I am a junior operator. I want to submit it to a senior operator to review this. I submit this and another operator, let's say I log out and another operators come for me as a junior, I cannot approve. It can be defined in the system, something like this. But let's say because my user is super user, I can do all of this in reality. But like I can review this. Okay, I don't want this now. It's just probably this is wrong, and I just delete this and I can say, all right, cancel it. I don't want to can't do it and deny. Just it's not. These are things that for switching management. And then let's say I'm happy with that, and I say approve. You can just initially approve and return it back, or just approve it. And then on the day that and it does a lot of validation, and we have sent a lot of commands. For each of this command, it tries to run the validation in the background. Sorry, I think it might take a while. I don't know how many operations we had, 61. Okay. And after it did the evaluation, also you can do some stuff like this, like you go to here. And if you select this, it shows where the command is, right? So I was disconnecting all of this, solar panel, and this number is number of operations. So I was 56, right? In here, like if I go to here, you see that's the number 7 in my list. So this was showing like what would happen. Okay. So for each of them runs a load flow. That's why it takes a while. So because you're disconnecting some solar, so now want to see, okay, when you do this, what will happen, right? So and then next one. So maybe I skip the violations validation here, if I don't need to do so. So and yeah, I can just complete it or execute it and things like this. All right, so it might take a while for that to come back. So let me see what is in my list. Okay, I was actually wanted to show this one, I think. Here, you see the curve that I was explaining. So you can, I couldn't find which element was it, but yeah, so this is the wind schedule I was explaining to you visually. It's like it starts and it stops, and then after, like if it's too much wind, it stops. So you can define this if you have a wind turbine. I think with the DR monitoring, DR again. So this is like explain all of this. And like, yeah, DR control I explained, and I was just showing that how you can disconnect or connect. But I think probably I choose too many things to disconnect at the moment, so it took a while. Okay, so we'll this is what you were saying. Okay. Okay. Okay, so I closed the switching plan. Okay, so but I could execute one of all of them, right? So I could select and all proceed. So if I want to do multiple elements, I can select and say proceed, and it would do like those operations and marks it as executed. So maybe I just do one of them. So I just see where exactly it is. So this one is disconnecting this wind, yeah, is a wind one. So this is generator. So I was disconnecting all the DR. So what you do is just when you say proceed, okay, so okay, so again, it does validate. That's the validation I was saying. For each step was trying to do all of these validations and like internally would do that. That's why it takes a while. But let's say I issue this, and then it is issued means like not operated yet, but when we say update, it basically operates this, and you see it disconnects it here. You don't need to do this. You could do this without switching plan. I just wanted to show you like how other functionality of the system as extra thing. So yeah, so in the DR control, you could have like just probably it was like if you want to get a better feeling, you can go just to one substation and land one feeder and see like how that connect or disconnect would work. So if I go here, again, I have a lot of elements here. You can say, all right, I don't want everything, right? So I just want to look at the batteries. Or if don't have batteries, maybe I have solar, wind, maybe. Maybe all of them here is solar. Let me just select something that we have. Oh, this is more DR control, I guess, the DR group. So instead of everything, I just say, all right, where is them? Let me see what type of. Maybe it's good. Another good one really, because where's my badge? So okay, so I very clear this. Just want to send just like one simple one. I think I want to find these are too many things there. Yeah, okay. So this one, if I disconnect and just say, okay, battery. Maybe these are not dispatchable. Oh, here I don't have anything to control, so it's not okay. Mm. Yeah, okay, so yeah, so I can, for example, disconnect here and say I just want to see the batteries. Yeah. I think this one has some problem, I think maybe. It doesn't refresh it, I guess. But okay, so this one, like for example, if I have multiple battery, I can say start charging or stop charging. So I can send multiple commands here. For example, for I have two batteries here, so I can say stop charging, start discharging, or stop charging, and all of this. But it sends it to multiple basically batteries on their DAC. So this is kind of like group command. Yeah, so this one is, yeah, so since 50, this is actual like now, and then you can put minus 500 or something, and you can yeah. The other thing you can do, yeah, I think that's pretty much it. So this is, you can just do these things. Is that kind of like clear for you? I think just different part of the network, I think it works differently. So
But for example, for this figure, what if we just have like a solar system? That's mean for the blue color, they show that if all of our solar system like interrupt, the demand will increase to this one, right?
if you have flexibility with
No,
it.
I mean we just have solar system for this filter only. So if we see the blue color over there, that's mean all of our system, our solar system will like when it's like have no sunshine or maybe interrupt, the demand will increase to this one, right?
No, this is when you have a contract with the users. Yeah. So let's say I don't know, in your case, probably you don't have yet contract. So let's say people have solar on their system, their inverters, like it generates 5 kilowatts right now. And you have a contract with them, I can drop you to 1.5 if I need to. And from 1.5 kilowatts to 1.5 is 3.5. So that's the flexibility you can play with. That's one solar. And if like you have a feeder and like you have 100 of them, so 3.5, if it's all of them the same, 3.1 multiple by 100, it's going to be 350. And that's actually here because you can curtail the
So
solar.
it's by on the defined contract
Yeah.
that we put to the system. But we usually get the question that if all of the solar system stop, how could the demand increase up to after this?
Yeah, here that is shown in the DR kind of monitoring because you cannot control them. You're saying, okay, so I think what you're saying is not controlling them. You are
Yeah, we cannot
control them. Okay, so in that case, like let's go to that MS05. So you can go here and say, all right, in this feeder, I have you can put filter, for example, solar, right? So technology type solar, okay. And then you can say solar. In this one, you have one solar, for example, but like if I go to here, so it will show all of the solar here. And also you can put filter here too. So you can say, all right, that is the elements, but here if you put technology, do we have technology? So maybe we don't, but production, okay. Oh, okay, so this is shows filter, okay. But your group generating units. You want to see, okay, how much right now you have solar here. So solar for Montana Sky, you have 590. And that could be on the rooftop or on whatever. So
is the data for real time or
is based on the either you have measurements or from irradiation.
but for this time?
Yeah,
specific
for this time, yeah.
Okay.
Yeah, for this specific time, yes. And like, okay, you want to see whole system. So whole system is 5 megawatts. You want to see in this area, you can say that.
Okay, but if so, we have to like get the data from the solar and we have to plus with the power consumption of this either. That's mean after that we have the demand number, right?
Demand, yeah. So the demand, I think if you want to see the demand here, you see injection, right? So this is consumptions, this much you have consumptions, that is DR total. So these are all the DR, not solar, because you can have anything. And then these are producing this, then yeah. So if you, for example, consumption is 23,000 minus all of this production, it would be this. So this is injection.
This injection
Yeah.
will a lot of type like DR. So if we just want to like think about the solar only, so we have to use this one.
Solar only, let me see. Okay, if we have only solar. I think for this one, I'm not sure if we can choose the technology here. Technology. I think you cannot use the technology. Why? Because it's for this one then doesn't make sense. Like, right? I cannot use that, but like, yeah, I think if you want to see just solar here, but yeah, it's solar is here, and yeah, I mean, maybe the information is in two places. Yeah. But like from this, yeah, yeah, but maybe there is some way to do that. Like, I need to check that as well, like maybe in another system. But this DR monitoring is where you can look at. So if you just want, I don't know if this one is good. So because it has the injection, this is the name that this is exactly what you had. So this is this 22488 is the same as this, is the for all areas. So this is your injection, but then solar is like you can just see here. And it's production. Undispatchable 584. So yeah, it's not quite like those together because really it makes sense when you have multiple type of solar. You just want to see like DR total. Really, you just yeah. You are saying if the sun, okay, they ask you if okay, we have this much solar, what happens if solar goes? Do we have a violations right now? I understand what you're saying. Hmm. But the other thing I would suggest is like you could use also this forecast as well. Like if I go, let's say to one feeder, just maybe it's more clear. Let me see. I think when I show forecast for you, then you would find okay, maybe you can use that as well for some of these things. It's not real time, but is actually it might be even better because they tell you okay, you want to see what happens in few hours from now. So here, like you see, you have a specific one for solar, right? So let me just remove Q because it might confuse. So consumption is green, right? And the injection is this orangey color, like, and the solar is this. So here you have some weather data. So if I go here, so it's so you see the temperature is like this and irradiation. So the sun is going up and down, and maybe this is a little bit wrong, but okay. Yeah, so that is that's why we have this. Maybe in another substation we have more solar. Yeah, you can see the impact of solar on this. So here, if they tell you, okay, if you don't have solar, so then it's going to be the green one. Yeah, because the green one is consumption without generation. But it's like any DER would be separate. But here, because I think we don't have other types in this network, so but you can kind of like get a feeling of this. And then if you hover here, you can see what you have. You see, and it's forecast solar. There is 21 megawatts, and yeah. So, but generally speaking, so this is like your base load. Let's say that green one is your base load without any DER. And if in this case, I think we have just solar mainly, but like yeah, we don't separate that kind of. Yeah. Yeah, maybe I think for you, what from what I see is probably this curve, like this value here from injection here. Maybe it's helpful with the solar. Okay, you need to do manually, probably check that. So. Okay. Okay, anything else you, I think that's pretty much it, so,
Yes.
yep. Now I have. Yeah, we have this DR overview report as well. So I think maybe I quickly show you overview. I think I covered this already. I think I was showing this one to you that okay, if you have a flexible contract, so if you have a contract with those one, you can sit here. I think that's, yeah, we covered this somehow. Yeah, in another one. So I think that's it. So, but you get more information here. So. Yeah, sorry, I think I explained this one before already. Yeah, so this one I explained and maybe we just go quickly to some of the attributes. So this is okay. So maybe we
So
just
for power contribution of the solar system, how could you like,
fault contribution.
yeah,
So this is like based on the rated. So let's say it is 1 megawatt. So if you have a fault, it contributes 1 megawatt to the fault. You can put it 70% or 80%. So basically whatever percentage you would put, that means that much would be contribute to fault. So it is, I mean, like for your case, we don't have anything but energy resources. Okay, so we don't have that module. We don't, it's not useful for you, I think. So I just quickly go to like see what information we have. So this is the type ADMS. Okay, AOR, we discussed it. So capacity, charging power, it tells you this circuit and container, you don't need to worry when you place it on the network, it tells you what it is. But then we have this contract. So contract, there are two different contracts. There is one here in the network model. One is what we have as a in the registry database. We shouldn't confuse that because some functionality uses this, for example, load flow, and the other ADMS functionality use that this contract, but ANM and the lookout and stuff like this uses the other lookout, which it has more information here. But here, for example, it says maximum power, ramp up, and stuff like this. So and dispatchable is here, right, as well. So you can say dispatchable through. I think that's the one that we might want to have. That means you as a utility can just send a command to it. If you cannot send a command to it, so dispatchable should be false. Okay. And I think this minimum power and maximum power are mainly more important. So don't worry about the ramp and stuff like this. But yeah, so you can go up to 10,000 and minus 10,000 because the battery you can go to both sides. Okay, so then charging power, fault contribution is not important. So fault type, okay. And this one again, the main node is calculated based on connection to the network, normal feeder, that's okay. Rated kVA. So sometimes your rated kVA is different from like charging capacity and things like that. Sometimes they're close, sometimes it might be a bit different. So you have this, and then you have this regulating. So I think probably I need to explain these regulators because I don't know if we covered it in the last week or to this week, because you probably would better know about that. So I need to go to Builder to explain it better. So let's pick this one. The way I do normally, I just get a custom ID. You know, custom ID is unique. So if you get the name, so if you can't put any name and it's only unique for that container. So sometimes it might not be helpful to search for that. So this big number, don't worry, it's a big number. It's a computer generated a unique ID. But if I want to just understand exactly that one, just I can use that. Or I'm just waiting for network model build comes up. So, or maybe I use this one. Okay, so here Control F, like a sometimes you're gonna start learning the shortcuts. Control F is easy. Every software is fine. And locate. Okay, it says I cannot change it. I don't need to change. And all right, so this one is a battery and locate in the model browser. Okay. Yeah, okay, so this one is the battery, and I think here you see the same kind of like attributes that you were seeing already. Don't worry about that for now because we covered it already. And then under this, you see this element called regulator. So if you want to send a set point to any element, you need to have this either like transformer you want to send a set point or battery you want to send a set point, you create this. And this battery, this is okay. So it says you see mode is generating active power. So you create that one. And then there are another element under this, which is the control setting. So you have normal case and fail-safe case. What is normal case? Normal case means you have a normal operation of the network. This set point will use. You can say, all right, it's not normal situation. I want to go to a fail-safe. That's like default, basically. You can put a set point, another set point for fail-safe. So it's going to be, sometimes you have that. Sometimes it's not mandatory to have it, but the mandatory one is this normal one, okay? And then under this, the control setting here, there are some elements maybe you can just want to update. So for example, bandwidth and set point, normal set point. So this normal set point, for example, could be 0 for battery. You don't want to send any command. For voltage regulator on a transformer, it could be the base voltage on the secondary side. So your base voltage is 22, you put the normal, that one, and the bandwidth also maybe is good because when you send a set point, if your value is between these two bandwidth, you want to say it's okay, right? So, and I suggest that to update this bandwidth. Depends on what type of point it is. So you see, because it was active power, here it says kilowatt. So this is 0, but okay. I mean, we can change this later. And then under this, we create this set point. And you see that this is read and write because we want to send a command, right? Set point, active power. Okay, so 3-phase. These are showing disabled because I connected not to change, but I can just make it change as well, like if I want to, but okay, I don't want to change. So it shows gray. And then if I open this, it shows the the remote point. So remote point also is the one that actually connects to the RTU. So it says DMP3, and then you have the name of the RTU, and then you gonna have the registry of that. So so this is where is the registry? Maybe here. Okay, sorry. Scaling factor. Okay, so this is the data master is Renoir on this one. Okay, so you have the set point to send. So this is this. Then for some applications from DERMS, you need high and low and transactional transaction schedule. You see this little you had a different from these and these. These are like array. It's not one point, it's like multiple points, similar to weather forecasting array. Here, what does that mean? So you can send the set point for now. You can send a schedule in the future. You're gonna say next 24 hours. The next hour be like this, next hour be like this. And you can send a set point as an array to that. So if you wanna send a schedule, you use this signal, right? So this one, the type here is the signal type is transaction schedule. Okay. And number of points. So what is important here? Number of points. So probably if you want to send the schedule only for next 24 hours, 24 hours. Other, it's going to remain empty. Maybe just in sense, it's better to have like as close as to what you want because it just uses spam or unnecessarily, right? So that number of points is important. This one is important. All right. So what is the difference between the high and low and that transaction? The transaction schedule is for set point. Sometimes you want to say to the battery, I allow you to go between this high and between this low, and they can choose to between those two and high and low. So those are same to the transaction is like array. So if I select this one, that's they call it operating envelope, so operating limits, right? So you can call it high limit and low limit. So this is clear. So this is the
Can I like this is the battery, this is the regulator for the battery. Inside the regulator, we have a lot of like set point. We have constraint like high, low, and some transactions get scheduled, right?
Mm-hmm.
And so for those constraints, they use this telemetry point to set the power to battery, right?
This one is for real time. So you send a command and they have to execute it now. Transaction is for future. You can say right now it's like, I don't know, 10 o'clock, 11, 12. They need to accept, they need to basically, it sends to like interface. And then they need to accept and understand that and be able to.
But how could we like send the schedule to the battery through the push point? Like they have to like have some point to receive the transaction schedule from the system, right?
Yeah, so that battery or aggregator or whoever controller, that controller should be able to receive that. Yeah, maybe not all of your devices can use that. Fine, just the real time will be sent, and they need to when they get it, they need to apply it. So we have two types of applications.
But they have to we must do some kind of like define the address between the battery and system. So in the transaction schedule, I don't see any like mapping address for the devices, right?
Mapping
Can
device.
you like the transaction
Any transaction. So basically, this specific signal belongs to this battery, and that battery is here, right? So this battery.
But how could we send the schedule to the real devices?
Oh, like you're thinking of, okay, SCADA has a like ID and you can.
Yeah.
Okay, got you. So the set point is SCADA, okay, so it's DMP3 or IC or ICCPU, this is up here. These are sent by interface IEEE 230.5. And for those IEEE 230.5, there is like some key for transaction and that data will be sent through that. So it's the interface.
Okay, so you mean those like conference like high load transaction just pop in the 20, 30,
It's actually
okay, but we have some device, some.
Yeah, it shows some care here, but like it's not gonna be used, like it just shows for user information. When we run this, maybe we go to the real times. I don't know, maybe we don't have anything there, but
Being the copy your camera.
Yeah, we don't have a.
But how could we like communicate with the battery with two protocol at the same time, because the set point you use DMB3 and the transaction schedule you say that you use the other protocol.
yeah, it's two different applications.
Yeah.
Because normally we will use the, very say we use the indication between them.
Because it's not like. Say that. It's not really real in real cases, because when you want to communicate with the devices, if you choose one protocol, you want to use the transaction schedule, you choose the protocol 2030.5, you can use the set point from this protocol, right?
Yeah, you're right. So in some, I have both of them on the same device to show the functionality. In reality, this battery from this company, you only can set point. You need to add only this. You don't need this. In another company, they can get IEEE 2030, so then this information sends from this. And transaction, when you send the first set, the first one is actually the one that they need to apply and has a timestamp, right?
Okay, but because I just want to know more information about how to do the configuration for this protocol. It's quite new for us, so I just want to see the configuration on some like.
Configuration is done through that IEEE 230. I can show you. I'm not expert on that protocol, but because again, similar to the other ones, this is kind of like we sold the license for now, and then if you want to use it, we can have like another sessions and to have that. But the document is there, and I can give you the kind of like keywords that is used for each of these three. If there's a code in the IEEE 23 that is only for this, one code is for this, one code is for this. I can give that information to you.
Okay.
But right now, we're not covering it here now, but just want to see the concept. Yeah.
Okay.
Yeah.
This concept.
Yeah, concept and like what would be needed. So yeah, if you don't have this, only this signals. If you have here, which signals is used for what? And like when I explain the applications, I wanted to do it later when I explain the applications. I just wanted to briefly tell you what the data and signals is required, just to have some understanding of this. Okay, these are things. The next one is control setting, right? This control setting is basically tells you active setting. It tells you this mode is on normal or basic. User can choose between these two. Okay. And when we send a command, that command from the basic or normal will be sent to this. Why do we have this? As I said, if you want to go back in some cases, normally the application sends the set point to this normal one, and then if you don't want to set point to be used, we can switch back to the phase. Yeah.
Okay, in the real time here, so if I go here, how does it look like here? It shows everything here. So the signal type is the one that you need to look, but okay, sometimes you see both of them are high. You need to look at the element name. So this is fail safe and this is normal. Like for example, I want to send a set point. You see, remember we had a remote point, and that's the one that I want to send a set point. So I can say, all right, my set point is like for 100. I can send the set point manually, right? Or from that DR control, we could also use this as well. Active setting is here, like here. So you see, in this case, I think we don't need emergency and voltage reduction. Okay, we can disable this. But yeah, so you can say, user can say it's normal or fail safe. Okay. And these two can be removed. Okay. So I mean, we don't need all of this because some applications they use more than one mode, and we can have like multiple of this modes here. So this control setting, you can have 4 of this. Some application use 4. So in this particular case, probably we need to just say, okay, you have only 2. Okay. So that enable also is that means this regulator is enabled or not. So if it's not enabled, then they see here is the application's not going to use it. So you need this one. So these are kind of like the kind of signals that you would need for but you can have extra. So let me just find another element that has extra elements. Just where is that one? DR control or DR monitoring. I just want to go to access maybe. Yeah, so this one, you see, it has a state of charge. So it says 50%. So I suggest that if it's very good to have that information in the system. So if you're asking to some batteries to provide you some signal, so this is another example which more yeah, so this one you see, okay, it's another place. Okay, so this is somewhere else. Okay, and then you have P regulator, and then you could have Q regulator. So that means you can control Q as well if you want, but it's not mandatory. And this state of charge, it is very good to have. So this one, it says 50%. It could have percentage, or you could change this to kilowatt hour. So this is possible to change that. So the type is charged. So what else? I think the signals we covered, attributes we covered. For yeah, other types is similar. So you can have distributed generator, and distributed generator can have PQ. The only difference for distributed the solar is like you cannot increase solar in general, right? So you can always decrease it. But yeah, you could still have that PQ because that actually is in the let's say the device can get a set point for P if they can, and they can drop the P and also change the Q. I think I have information that I wanted to cover for this part. Do you want to continue with the break or just continue? Or I can go to the next one.
Maybe we can continue after lunch. If you want to continue, so in this morning, so you can continue, but I think the best is after lunch, right?
Up to you. If you we can be flexible. You can go, yeah, whatever it suits you better. Yeah, we can, because yeah, we covered that. So so we are here for you. Yeah, the next one is, I think the topic wise is hosting capacity. I was planning to do it in the morning, but if you want to get a short break and then like 5-minute break, and then we can do that hosting capacity. It might be quick, this one. Let's cover that, and then we go to the active network management in the afternoon.
You have, maybe we can continue and skip the break because.
Okay, skip the break. Okay, no worries. This hosting capacity, I'm hoping that it doesn't take much of time. So, yeah, so this one is for planning, as I explained this morning. So we have model-based and non-model-based. So I think this information is kind of like redundant. I have it in my presentation to have my complete presentation if somebody wants to use this presentation, but this is redundant for you. Like, then what hosting capacity do is you can firstly, you need to run it in the simulation in context. So let me just open that simulation context. While we are talking, maybe I don't need this. I'll close this one. And DMD, so, and need to go to simulation, modify the context. So I just put like North America for now. While this is loading, okay. So what is the hosting capacity? You want to know how much extra generation you can add to the system without breaking the system, like really violating constraints and stuff like that. So why we have the input necessary, like topology and stuff like that, the rated power for those elements are important. So rated power for these elements, for rated element for this one is also important. And then this one is. So firstly, you need to open the application function manager and anything else. Like for selection, you select a figure or substation, whatever. Then there are some options here that when you select this one, this appears, and there are some shortcuts for coloring here. So let me explain. Let me change my glasses. Okay, so this one we want to say we're gonna add 100 kilowatts, right? And in steps. So I start from 100 and then we add 20 kilowatts, 20 kilowatts, 20 kilowatts until we reach the capacity. Okay. And then you can say, all right, I want to have like a power factor like this. Okay, that's fine. You want to check voltage violations because if you want, yeah, select it. If network is not quite tuned for voltage violations, it doesn't need accurate impedance data and stuff like that. If it's you don't want to select that, you can just unselect this.
target transformer loading. Remember when I was showing each section or transformer as a rated value. So let's say for a transformer is 5 megawatts. So you can say 100% of this. You can say I don't want to reach to 100%, I want to reach to 80%, and then you can change that. The second one, I think maybe when I connected, I can show you. Like we had 4 limits of up to, I mean, it's flexible. So you can have different limits for that one, and you can choose between those. Relay select, if you have a relay data, relay set points, you can select that, and so on and so forth. So maybe I just run once, and then here, oh, we have methodology. So this one heuristic, so it's kind of like not running load flow itself, but it's a very simplified load flow. Simplified load flow means just using aggregated values. So that is more faster. So heuristic is more faster. Accurate is less accurate. Yeah, it goes up. So this is faster, and the last one is the very last one. So you probably will need that if you have a really, really good data and you want to use voltage. So you don't need to think about that. Maybe you start with the heuristic, and you can get at least some data about this. Then we have this one, which I will explain further. Current load and generation. In the simulation context, you have some data at the time when you simulating it. So how can this be derived? You can use profiles, daily profiles, right? You could use a state case from real time. So you, for example, when you are running your system, at certain point you say, oh, I want to use this as a placeholder for my studies. Like let's say it's a high load or low load, either way. You save that state case. Did I show you how to, I think Farhan maybe showed you how to do a state case? Yes. Okay. So at certain, like some, I think makes sense to do studies when it's very high load or very low load, right? So you could use that. That is kind of like this. You don't say this before. And then the next one is period. So period means, okay, I want to study for next 3 months or next year or the whole year. You can study that one and then select this rest of options. I think probably I need to show on the system because it's disabled here.
Okay, I will explain for the rest of functionality a little bit. Okay. Okay, so you guys see this screen on the system, okay. DERMS. Okay, I just keep going with this Montana Sky. I just random like with a MS5. I think I did before, but okay. All right, so I select heuristic for now, and I use default. Let's use 80% for now. Just to have different values. I select a supply transformer as well. Supply transformer in ADMS technology is like your HV to MV transformer.
MV transformer.
Yeah. So that one you could have a different value. Like I don't know if you want to go 120%. Just
the transformer in the substation.
Yeah. And this one DR penetration level. Okay, so you can say I want to see penetration.
Then like the penetration
Yeah.
in the feeder or inside the transformer.
inside like distribution transformer. So it simulates the MV network, and it says, okay, let's say you have 100 customers, 20% of them will have this DR. Like it,
Because I just confused that, but said this representative for what? Or for how heat of the drain from our inside station or for customer or something. The connection was not supposed to random. The connection.
so what happens? Okay, so let me just explain. So maybe we run it once and you can see what it means. Let's say I have this network, right? And then I have, like, let's say each of this one is a distribution substation, and it has like this many customers on this one. This one has 0, but bad example. But let's say it has, I don't know, 100. So 100 DRs is simulated on that one, and 20 if I select 20. Yeah, so customers. Why we don't have customers here? Maybe we didn't import. Oh, this one we have. Okay, 5. So 20 is like one of them will have like a DR. Yeah. And instead of 500, probably you can say, I don't know, a smaller one. So you can say 50, and then probably you need to increase the step as well, like 10 maybe. You know what I mean? So let's say, and then let's run it and so means that at this point, we put at the beginning we put 50, and then we increase 10 by 10, and then either host capacity. Okay. Yeah, when I selected that, it has the color. I think, sorry, just let me do it again. So yeah, okay. So let's go to the contract sheet file. So this one, you remember we had the legend. So for if we want to interpret any coloring or something like that, we need to go to and show this legends, right? And so this section that are marked as red, it means that we can put hosting, we can put up to 2000 kilowatts of power. Like it's any of these, like for example, here or here or here, we are limited by one up to 2000. We cannot put more. So if you have more capacity, if the greener is better, like you mean that you're not limited. So maybe 2000 is not really good. This range is not quite good because it doesn't differentiate with everything. So everything is like this. So I think what I could do, I can go to options and go to hosting capacity. Maybe I range this to, I don't know, like 200, 600, 1000. Like let's do it like this for now. Just for now. Just want to get a view of this, and then Yeah, okay, I need to just need to check that. What is the problem here? Yeah, all of them, they have this one. I don't know. There is some, maybe I use another feeder because they are all hosting capacity is 0 because I think maybe we have some critical sections. Um, maybe I play with that. Let me just unselect these two for now, and maybe I just reduce this to 5. It can be 5. Okay, so then okay, so I get some different results here. Yeah. All right. So now if I go to the network view, this color is the hosting capacity is, for example, for this point is 905. What does that mean? If I go to this point, you see this rectangle, that means in this location, I can install up to 900 kilowatts. And critical, so it's the maximum hosting capacity at that particular point. And when I install this, if I go one step higher, you remember I had like every 5 kilowatts. So if I go one step higher, it's going to be this, right? It's going to be 910. And then this would create these violations. This would create this violation. Maybe some of these things was already violated. So I can locate this. And you see this element, it has, I think the colors a little bit like overlapping on each other. But if I install that 905 kilowatt on this one, this section will be overloaded. And what it would have is going to be, and KVA is like this. Yeah, because I selected also 80%. You remember I selected 80% here. 80% of, so this is it's going to be 120 ampere on that one, which going to exceed 80. So it's going to go 80, 0.2. Did you get what I mean? So for one individual one. So each node on the network, it would say how much power, like a generator you can install there. So on that point, so and like here, what is the catch here? So like let's say you want to study your system and you want to add some basically solar or something somewhere. You want to know where you put it and your network can handle it. If your basically battery is 5 megawatt, you sort this like this, and they say, okay, this one cannot afford this one can afford 5 megawatts and more, but this one cannot afford 4 or 5 megawatts. So the locations that you probably want to look at this are all of these locations here. So, you know, and if you put 5 megawatts, it's less than this. So your violations when it's going to be in full power, it's gonna be on this particular element, and it's gonna be like that, like 140 ampere. If I select it here, yeah, so that's the worst case, because this is the weakest point of your network. Right now, if I let's say turn on my load flow results, let's say, because ampere is 114, okay. And if I add this 5 megawatts, right, instead of 114, it's going to be 184. And 184 is 80% of that section. So if I go to that section, you see, let's see the sorry, my monitor is okay. It's on the catalog, the rating. None of this. And normally you can select what is normally you check. Okay, so I rated current is 230. So 230 multiply 80, right? So if I just do a little calc for you here. Two 30 multiply 0.8 is 184. That's why here we have 184 here. Yeah. So is it give some insight? How can you use this application in theories? Yeah. Like you need
Just have something for the penetration index. Because when you choose the option, we can notice some more DR in every segment of the feeder, right?
Mm-hmm. Yeah. Not that point, okay. When I raised this, it was without this. Let's see. I think it shows 0. There is some problem with that. I think I might need to double check without like
Because
colleagues.
I
Yeah,
think
it
we have
seems.
to understand the percentage of one, like the
Yeah.
capacity of the segment or the total number of the ER. Is it in the segment or something? We have to understand that.
Yeah. Okay, so um
Similar level of 20%.
yeah, it's basically 20%. I will double check this one. I think it's not quite working as well. I think maybe it works with this accelerated. Let me just see. Okay, so there might be something incorrect or yeah, this one that takes a bit more time, as I said. Okay, finished. Yeah, I think maybe that option has a little bit. Yeah, I think we couldn't calculate it. So I will double check that one for you, okay? I will either have a separate session for that when I have the information. Yes, 30%, 70%. It didn't show zero here, it shows zero here, but it shows. This is a bit, this part. Yeah, I will come back to you on this one. I think yeah, you're right. So it's not quite clear here. So, okay, yeah. The other options on this one, like I was about to just explain. Okay, so let's not select that one for now. This one, the periodic. So I was explaining to you, you could do overtime because the problem for this one is like it's just for 1 point, and you want to see over the time how it would work. So you're gonna select the period, use forecasted load if you have forecast data, but if you not use forecast, it uses daily profiles. Like you got a daily profiles. So if you select coincidence, that means maximum. When you say maximum, so it's maximum demand. So basically means that generations are off and the loads are in maximum. When you say minimum, it's the other way around. Your generations are maximum and the loads are but coincidence means like they are at the same time. It looks at the profile, load profile. It finds like in that load profiles a time that both basically internally it calculates a curve as maximum and a curve as minimum, and it finds 1 point that both time are like the same time. So it's at the same time. But non-coincidence is means they are not at the same time. It could be in the curve. They could be, let me explain, I think a little bit complicated when I explain it like this. In the forecast, maybe it's easier to see what I try to say. Like here, you see, if I say coincidence, it does look at where the maximum is, and both of considering both. Basically, this is injection. It's your maximum is here. When you have consumptions and when you have solar, like combination of those make it maximum, which is that injection part, right? So it's going to be this point. And then minimum is this point of time. So coincident there at like everything happens at the same time. So, but when we say independent, which is the next option, when it's non-coincidence, maximum load, let's say I selected maximum load and no generation. What does that mean? If I go to the other curve, so means no generation is here, let's say. I mean, like any point of this can be used, but maximum load is here. So it doesn't look at this injection anymore. So it's basically maximum is this one or this one is this one. It will, I think maybe they're almost the same, but like maybe this one is highest. So maximum load is at this time, 5 p.m. and the generation is minimum, right? And the vice versa. So you can have like look at the minimum consumption and maximum, which are two different points, right? So in this case, your minimum generation is at like 6 a.m. and maximum load is at 9 p.m. Okay. That is it. This is okay. Make it more conservative or less conservative. Let's do this. So this basically, if you select it like this, let's not use forecast for now. Maximum load and no generations. That's like very conservative way, and we can see the difference. And it would take more time. Okay, it is done. I go to the same. Oh. Okay, select. Oh, I selected this one. I think this looked like to me. Yeah, I have, sorry for that. I need to run it again because when I use that, it shows this 0, which is not great. I'm not sure if when you select that, we need to look at this or that, but your penetration is the percentage is lower now. It was 130 before, 84. And this one has both results. So what I expect the values are less than this when I run it with that option, most likely.
Maybe the penetration level of your system show that the total DR in a feeder compared with the feeder capacity. Because I see the same figure, so maybe this feeder.
Yeah, they're all. Then
Can
double
you check
check.
capacity of your feeder? Maybe
Okay.
and the total capacity of the DR, so you can.
The total capacity is okay. So total capacity is yeah this one. Less voltage and loading capacity 310.
Around 500. 500 ampere.
Okay, sorry. That's so one thing while that's running, so I think just if you want this system, I do this like for example things that are important for me to see. For example, the name of this is section, right? So I want to see like always see rated power because that's important for me. You go here and select the element, and that element is what you see here as a type section. And then not season, sorry, section. Okay, you want to let's say add rated current or rated voltage. So if you are interested in both of these, always you select that here and then you apply. And then when you refresh it, so next time you open your system, it always shows how much rated current is this. So you don't need to go to here to scroll down and up. So the important attribute, basically, you can select to show of your interest, basically. And yeah, so it's you go to here. Okay, so that one it runs a lot of, I think, load flow and for different times it's a little bit slow. So you can basically, yeah, it's for studies and you can leave it there and just come back in 5 minutes, whatever it takes. That's why I was like not doing yeah. We got another applications called customer connection, but I think we don't know that you're gonna use that as well or not, but so it is not added to the system, I think. Let me see. Customer connection, we don't have it here. Customer connection is similar to this, kind of like it. You can just add like a new point and different points, one point or multiple points, and see what is the impact of adding those type of customers. Yeah, this one. Yeah, look, I mean, I guess we can wait for that, but like the display results will be similar to this. So if you wanna like have a look at like what exactly other results are important here. Yeah, the results is this table is the same as this. And probably I didn't show the overview. Overview for this one, it says how many locations are in this capacity under like between 600 and 1000, and how many person on here and how many person here. Your maximum hosting capacity is 11,635, which is like if you go here, it was the top one on this list. So then the range of DR powers is between this. So in worst case, you could do 850. So yeah, I think you could use this basically display to see what is that. So it's, if it's sorted by basically increasing, is 885 is the first in this list. And then this is the last one. So that's a number of kilowatts and consumptions in the system already. And I just need to get some more information about this DR penetration for you, I think. Maybe I should select like a smaller range of the dates. So maybe, okay, so sorry, I stopped this one, and maybe I just show it in the afternoon because I think it just takes too much time. So maybe.
I don't know what's the process for calculation, but I think they don't just like pick the maximum point. And after that, they will do the calculation, but maybe they calculation for all the
Yeah, for whole
graph.
yeah, for whole graph. Yeah, every 1 hour it just do one calculation. And I think I was using accelerated. Accelerated already takes more time. So I make it heuristic. I just make it 2 days between these 2 days. I think I can do it 1 week, but okay, just to show, I think, yeah, just I mean, like it just takes more time. So if you and this network is quite big. Yeah, this one was quicker because I used accelerated. So sorry, heuristic. Yeah. So yeah, you see the values are different from the other ones at 12,000 and the 11,000. Yeah, so the values calculated and they calculate different values when you use this one. Yeah. And if you want to check what you did select, you can always go to the report and select this to see what you selected. So this was 10 and 5 and heuristic. And this report we had like 10 and 5 and just concurrent. So you want to compare two studies if you forgot what you had. So yeah. One little thing you can just change the name of this. So if you have two studies, if both of them shows 1, you can just change it to 2 to see, okay, when you can differentiate. This is something, it's a simple thing you can do. Yeah. So this is a high level of this. And I think, yeah, this coloring, I think I showed already. So you've gone video hosting capacity or location. So locations is like each node that you have, it simulates on that part. Substation, the whole substation shows 1 color if you have more than 1 substation, but we don't have right now. Yeah. Yeah, these are all feeder DR minimum power. It's like between 6,000 and 1,000. Yeah.
But is not the capacity function for like generation, right? But what's the difference between the hosting capacity load?
Oh yeah, that's for generation. So here, when we simulated generation, right? So when we added here, we were assuming we add generator. And if we use the other one, we'll actually assume it is load.
That's mean where is the best location for this only rainfall or something like that. Right? For this concept.
Yeah, so how much load you can add to that point. So previously, for each like node, we were simulating how much generation you could add, and it's not gonna break, so we're increasing to see when it breaks. And now we add the load, it's kind of negative with that, so. Yeah, the concept is the same.
Yeah, but I need to, this one, I need to, just double check for you the exact, like what is the exact meaning of this and what is the expected behavior for this DR penetration and come back to you. But I don't know, like which one is probably, both of them is useful for you or just one of them is useful for you is probably, that's fine, you can use either. Yeah, I think that is, let me see if I have anything in my presentation. I might have missed here. It's just the explanation of this hosting capacity is just without load flow. This is with load flow. This is full load flow. That's fine. And the heat map is just the coloring. I think we already discussed, and I showed this one. So yeah, and I don't have much to explain, I think, but except that I have to take action to get that information about the one option a day. Okay, so we can, I think, stop now. It's 11:30 already, and we can do active, negative tomorrow and flexibility after.
Okay, thank you for your lesson.
Hey,
See you after then.
And yeah, sorry,
It's the bonus.
maybe it's in meetings or something.
So he
It's so big.
Maybe you pause the recording because